So in this example, we're concerned with the researcher who's studying the weights of state quarters and traditional quarters. He takes a sample of 18 state quarters and 16 traditional quarters. The null hypothesis is mu1 equals mu2, that is, that the two quarters weigh the same. The alternate hypothesis is that mu1 is greater than mu2, that is, that state quarters weigh more than traditional quarters. So again, the first thing we have to do is enter the data into the table. Okay, notice in this case I'm not going to calculate any differences because these are independent samples, unlike the hotel example, which was dependent samples. Alright, so what I do here is I go to Stat, I go to T-Stats. This time I'm dealing with two samples with data because this is two independent samples. Alright, so I select my first column, which is state, the state quarters. My second column is the traditional quarters. Make sure that pool variances is unchecked. Now here's where it gets a little unique. Remember, our null was mu1 equals mu2, which is the same thing as mu1 minus mu2 equals 0. This is the way StatCrunch handles this. And then our alternate hypothesis is mu1 minus mu2 is going to be some operator compared to 0. If mu1 minus mu2 is greater than 0, that implies that mu1 is greater than mu2, which is what we were going for because we would have a positive value there. So here's our hypothesis test. Let's go ahead and do a p-value plot and compute it. And so there is our information. We have a p-value of 0.0086. We have our t-stat of 2.54 approximately. And let's go ahead and look at our p-plot here. Notice we're in this area here. We're looking at greater than, so again we have this value here. Okay, so we were looking at a level of significance of 0.05. Our p-value is less than that, so we will reject the null hypothesis. That means that state quarters do weigh more than traditional quarters. Okay, so on the issue of a confidence interval, we're going to get slightly different results depending on how we do it. These different results are due to rounding as well as the discussion we had about degrees of freedom. First, let's just start off by doing it using a two-sample with data based upon what we have here. Just this time we're going to click confidence interval 95. Again, we select our columns here and we run it and we compute it, and there we have our confidence interval with data. Now let's look at the case of doing this with the summary. And what that means is you're given the mean, the standard deviation, and the sample size of the two samples. So now this difference is going to be due to rounding, but let's go ahead and put in the information that we were provided in class. And there we go. Now we have our confidence interval in this case. I'm going to start off by discussing the by hand calculation that was done in class. the critical value was determined by using 15 degrees of freedom. Because remember, we had a sample of 18 and a sample of 16. We do n minus 1 of the smaller sample. So 16 minus 1 gives us 15. Notice the range here, and notice the range in the technology calculation. Notice that the range for the by hand calculation is greater than the technology, because remember, this is a conservative approach because we want to make sure that we include the parameter. We want to make sure that we include the parameter within there. So we're taking a much more conservative approach when we go by the smaller of the n minus 1 degrees of freedom. That being said, notice the degrees of freedom in the technology calculations, 26.96 and 26.98. Those differences are due to rounding, because remember, we did one with a summary and one with the data. The data hadn't been rounded until the final. While we used the summary, we used rounded data. But let's just take it. So where does this calculation come from? This technology degrees of freedom. So this is the calculation for determining degrees of freedom that will allow you to get a more accurate result. And as you can see here, I did the calculation on the calculator and I got that 26.989 number for the degrees of freedom.